The central organizing concept for calculus is the function. A function is an extremely general concept. Take one input, you get one output through any action, that's a function. Extremely general. The input can be a number, a color, another function, it can be anything. In this class, we'll be using equations to express the output of a function. And in general, this is true. This is the big step, pre-calculus, post-calculus. Take some equation. I'm going to think of this as, starting with x, I'm going to multiply by 3, and then I'm going to add 8. So 3x plus 8 is the output of a function. That function then is given the label of the output variable. That's the standard labeling scheme, y of x then. The elementary functions are the basis of all functions coming forward. Once you know the elementary functions, you can pretty much get you anything else in terms of them. Just like decimals give you all real numbers. There's our elementary functions. Adding and multiplying are odd because they have two inputs. If I think of it as one ordered pair of an input, then it's a function again. So taking 3 and 4 and adding them together, we'll be using this notation, the mapping notation. We can also think of it as an ordered pair being fed through the addition function. So that's one input, one output. And the same for multiplication. These functions are a little easier because there's only one input to begin with. X gets exponentialed. X gets raised to a power. X goes through the sine function. X goes through the cosine function. Anything you can do, you can undo. The undo is called the inverse. The inverse function, sometimes. Mostly it's never a function. Let's look at our elementary functions and look at their inverses. We have the exponential function and its inverse, the natural log function. We have a power and its inverse, a reciprocal power. Cube root is related to but not the same as this. Sine is undone by arc sine. Cosine is undone by arc cosine. So looking at the sine function, its undoer, the arc sine, is the inverse sine function, pi minus the inverse sine function, and 2 pi multiples. So this is called a multi-valued function because I'm generating all the outputs through a function, and the same for cosine. Powers are also the same. If I have a 1/3 power, that's really the cube root and the cube root times a complex number. This complex conjugate pair. So 3 outputs. These are all multi-valued functions because I can take a function, the inverse sine, the inverse cosine, the root, and from that function I can generate all the outputs. So this is called the principal part. And then all the other pieces I generate from these, the pi minus, the negative, the multiplying by complex numbers, the 2 pi multiples, those are my symmetry part. So my inverse operation is divided into the principal part and the symmetry part. This makes the exponential super easy because the inverse is already a function. Adding and multiplying are a little harder. Take my ordered pair and I feed it into the addition. And now I want to undo that operation. What two numbers added together give me a 7? Well, there's all sorts of numbers that can do that. So the only really pattern that we see is that whatever the first number is, the second number is 7 minus it. That's about it. That's the only pattern there is. This is a problem because now we have uncountably many outputs. So it's not very tenable as a operation. There is a special case that is invertible if I just think of one of the ordered pair as varying. This we can undo. The two notations we'll use are the above notation and this little tree notation. We use both notations. To undo adding 3, you subtract 3. So that has an inverse function. We'll suppress the comma 3 and we'll just say x add 3. There's the add 3 function, which we'll undo by the minus 3 function. Multiplication is very similar. I have an ordered pair going through the multiplication function. To undo it, I need to know what two numbers, when you multiply, get you 12. That's the same as the addition. Whatever the first is, the second's 12 over it. Uncountably many output numbers. It's not really tenable. But special case, if I just think of the first of the ordered pairs as varying and the second as fixed, then that's the times by 4, and we'll use both notations depending on context for this. To undo multiplying by 4, you divide by 4. And we'll suppress the comma 4. So there's our multiply by 4 function and our divide by 4 inverse function. Taking a little closer look at these operations, subtraction and division weren't on our elementary function list. Here's why. X is x plus 3 minus 3, but minus 3 is really adding negative 3. And as the definition for subtraction, you're adding negative numbers. In terms of the function, I'm adding 3, and then I'm adding minus 3. Rearrange the addition, and I'm back to x. For multiplication, it's the same thing, but you're multiplying by 1 instead of adding 0. There is no division, there's only multiplying by reciprocals. In terms of the function, I multiply by 4, I multiply by 1/4, reorder the multiplication to put the numbers together, and I get back to x.